Hey class, in this problem, we were to discuss the type of discontinuity of the function here over the set of real numbers. So we have to really recognize where the point of discontinuity is and which of the three conditions for the definition of continuity fail, right? So the definition of continuity said that if the function is continuous, if a function is continuous at some point C in its domain, then the limit as x go to C of f of x is equal to the function value f of C. Okay, so this is a one sentence definition right here, right? However, that mathematical sentence right there really implies three conditions. Number one is f of C must be there. And then number two is the limit as x go to C of f of x must exist. And then the limit have to equal to the function value. So there are three separate conditions to check. So when we're following along the x-axis here over the domain of the real numbers, we will see that f of x is continuous up until here, -2, right? So at x equal to -2, which one of these conditions fail? First, is there a function value at -2? And the answer is yes, it's right here. F of -2 is 2. However, the condition number 2 failed because there's no limit. And it doesn't have a limit as x approaches 2 because the left hand and the right hand limits are not the same. So if this condition fails, then we cannot remove it. It's not a removable, right? And this is a jump discontinuity. Okay, now the next point to look at is when x is equal to 0. Okay, which of these conditions fail? Is there a function value at x equal to 0? And the answer is no, because this is an asymptote. So there's no function value. And then also there's no limit because the left-hand limit and the right-hand limits are not the same. So this is an asymptote discontinuity. First condition fails, second condition fails. So of course the third condition must also fail. So that is not a removable discontinuity. And then when x is equal to 2, that's another point of discontinuity. This is a hole. Then when you have a hole, then the first condition fails because there's no function value at that point. However, there is a limit. And so if we were to fill in the hole like this, then the limit will equal to the function value and it will be continuous. So at this point right here, that is a removable discontinuity where condition 2 is met, however condition 1 is not. Then we just go ahead and assign the function value to be whatever the limit is, so that condition 1 and 3 also are met to be able to remove the discontinuity. Okay, so at x equal to 4, this again is a jump. However, the gap is not as large as it is, but it's a similar reasoning to the point -2, right? It's the same concept here. It's a jump. Okay, so that is what the question is asking for us to discuss that. So you write down what I just said. When on the test, you need to go ahead and determine at which point, and you need to use your written words rather than my oral words here in this explanation.